Hi everyone, in this video we're going to be going over writing in slope-intercept form. Our essential question for today is, how are equations written in slope-intercept form given the slope, points, and other equations? So once again, our essential question for today is, how are equations written in slope-intercept form given slope, points, and other equations? Now this is very similar to what we kind of went over last week, or in the last lesson that we had. But we're going to go a little bit more into depth on how to write equations given just those points and a slope, or rewriting equations. So first you've got a couple review problems to try that are on your foldable, and these are problems numbers 1 through 4. And this is just kind of a refresher from the last lesson and to see if we remember how to write equations based upon our slope and y-intercept and a graph. Alright, so first thing we're going to do is talk about writing from a point and slope. And I'm going to go over several steps here, and I suggest that you write them down. But once we start going through the problem, these steps will make more sense. So our first step is that we're going to substitute the slope for m in the slope-intercept form. You're going to be given a slope, and you're going to put that into the form very similar to what we did in the last lesson. This time you're not given the y-intercept, but what you're going to be given is a point. And you're going to substitute those points into x and y and solve for b to get your y-intercept. And then finally, you're going to take your slope and y-intercept and put them into your equation or your slope-intercept form, just like we did in the last lesson. So make sure you have this written down, and I think these steps will make a lot more sense as we start going through it. So our first example, we've got a point, -1 and 4, and a slope of -2. And our first step says just simply put in the slope into the equation. So we have our equation, which is y equals mx plus b, and I'm going to put -2 into m so that it looks just like this. Now what we have to do is we have to figure out what is b, what is our y-intercept, and the best way that we can do this is by substituting in this point into our equation. So all we're going to do is we are going to take -1 and put it into the x and replace the x, and the 4 and replace the y. And then we just do some basic equations and solve the problem. So -2 times -1 is 2. And we know that 2 plus 2 would give us 4, so b is 2, which is our y-intercept. So now we have our slope, we have our y-intercept, and we're ready to write our equation. So if you think about this again, we've got our y equals mx plus b. We know that the slope is -2 because that was given to us. And now we know the y-intercept is b, so we plug that into the b. And that is our equation. Let's go over one more example. This time we've actually got one with a fraction, which seems scary, but it actually is not. And our first step says to just put in the slope in place of the m. So we'll do that first. And I always put the parentheses there just in case there's like a negative in front of the x, and that way I know I need to do something with it. But in this case there isn't, so I can just drop the negative, and now our slope is in our slope-intercept form. But we need to find our y-intercept, and the way that we're going to do that is by plugging in the x and the y into this equation. So I'm going to take 2 and input it into x, and -3 and input into y. Now, even though this looks really scary, I'll show you how easy the math is, and just as a fraction review. All you need to do on this is just go, okay, so I've got -5 over 2, and that's being multiplied by 2, which is the same as 2 over 1. Well, -5 times 2 is going to be our -10, and 2 times 1 is 2. Well, and that just reduces to 10 divided by 2 is just 5, so that's a -5. So even though this part right here looks really scary, as you can see when you just put it in fraction form and start doing the work, you end up getting a really easy answer. So -5 over 2 times 2, then we found out, is just -5. And then to solve this, we add 5 to both sides, And we find out that again, just kind of like last problem, so it's kind of a coincidence, that our y-intercept is going to be 2. So now we found our slope, we have our y-intercept, and we're ready to write our equation. So I take our slope-intercept form, and we're going to plug in the slope into m and the y-intercept into b. So y equals negative 5 over 2x plus 2. And that is it. All right, you have 2 problems to try on your foldable. So take a moment and try those problems. Now let's talk about writing an equation just from 2 points. So before, when we first started this out, we had a point, or the y-intercept and the slope. Last problem, we didn't have the y-intercept and we had to find it. Well, this time we have none of it. We don't have the slope and we don't have the y-intercept, but we have to find both. So the only difference in steps from this is that the first step, you're going to calculate the slope from the 2 points. And then your final 3 steps are the exact same steps as before. So the only new step this time is to find the slope by using the slope formula. So let's look at some examples. So we've been given 2 points, and our first step is calculate the slope. And we know we have to use this formula, which is our y2 minus y1 over x2 minus x1. And when I plug this in, I end up with our 11 minus 7, so subtracting our y's, and 5 minus 3, where we subtract our x's. And that gives us 4 over 2, which becomes 2. So we found our slope. Now that means the next thing we need to find now is we need to get to a point where we can find the y-intercept. So let's take a moment and just plug in that 2 that we found for the slope into our problem. And now we know we've got the slope and we're halfway there. But now we have to take up one of these points and plug in an x and a y so that we can find the y-intercept. And it doesn't matter which point you choose. You can choose the first point or the second point. Both will give you the same exact y-intercept, no matter what you choose. So in this case, I'm just going to choose the first point. So I took the x, or the 3, and plugged it into x, and the 7 and plugged it into y. So 2 times 3 is 6. And if I subtract from 6 on both sides, I find out that my y-intercept is going to be 1. So we've got our slope, we've got our y-intercept, which means we're now ready to write our equation. Now we start out with y equals mx plus b, and we know that the m is our slope, which goes into the m, and our b is our y-intercept, which is going to replace b. And our final answer is y equals 2x plus 1. And that's it. So as you can see, all the things that we've been doing so far, they've been building off each other. We started with a slope and a y-intercept. Then we took away the y-intercept. Then we took away the slope and y-intercept, and we can still find the equation of the line. Let's look at another example like this. So first step, we need to calculate the slope. We have our slope formula, and we're going to subtract our y's and then our x's. So we have 3 minus 1 and negative 5 minus 5, which gives us 2 over negative 10, which reduces to negative 1 over 5. So now we have our slope, and we now need to start working on finding our y-intercept. So the first thing we'll do is let's just plug in that slope into our equation. So that negative 1 over 5 is going to replace our m. And we're super close to solving this equation. You can see that we're just missing the y-intercept, or our b. So now I'm going to take one of these points and plug in over here. And it doesn't really matter which one you choose. One thing I always look for is, okay, if I was going to multiply this fraction by one of these, does it make it any easier? Both of them are 5 though, which is going to work out really nicely because they'll both cancel out and give us a nice number. So let's just plug in let's say the first one. It's all positives, and we like working with positives. So this 5, which is x, replaced our x, and our 1, which is y, replaced our y. Now, just kind of a reminder on how to do fractions, just like I did earlier. Remember, this is just saying negative 1 over 5. Oops, there we go. Times 5 over 1. Well, negative 1 times 5 is negative 5. And 5 times 1 is 5, which means this all reduces to negative 1. So even though it looked scary, it's actually really nice. And we find out our y-intercept is just, that when we multiply negative 1 over 5 times 5, it's negative 1. And then to solve this equation, the opposite of a negative 1 would be to add 1 on both sides, which again, we get b as our y-intercept, so b equals 2. Now we have our slope, we have our y-intercept, and we're ready to write the equation. So all we're going to do now is take in the slope and the y-intercept and plug that in to our equation. And we find out that our slope of the line, our equation of the line, is y equals negative 1 over 5x plus 2. And that is it. All right, you have 2 examples to try. Take a moment, try those on your foldable. All right, our last part of these notes are on rewriting equations, and I think you guys will find this as a nice change from what we've been currently doing, and it's really easy because it relates back to working with equations. Now, when rewriting equations, the goal is to get the equation in slope-intercept form. That means you're going to be given an equation where maybe the x is on the left side or the y and x are on the same side together, and you need to move those variables or those constants around so that it is in slope-intercept form, such as y equals mx plus b. So for instance, look at this problem. Does this look like it's in slope-intercept form? No, because if we look at it, y is on the left, and that's good, and it's a positive y, which is even more important. But this negative 2x is on the left side, and we need it to move to the right side. And remember, when you think about equations, if we move something to the other side of the equal sign, it becomes its opposite. Okay? So when negative 2x moves over to this right side, it becomes a positive 2x. And then that's it. After we move the 2x, it's easy. That's our equation. It's already in slope-intercept form. Just make sure that the x is right here with the coefficient and not where the constant should be. So make sure you don't write it as like 1 plus 2x, because then that would not be in slope-intercept form. So pretty easy. Let's look at another one. So it gets a little bit more complicated. It has some distributing in it. But if you remember, all you need to do is just distribute. So you have negative 3, and then you are just going to times that negative 3 by everything inside. So just as a reminder, we did negative 3 times x and negative 3 times negative 3. And that gave us our negative 3x plus 9. Now, our goal is to get this in slope-intercept form, and right now it is not. But what's nice is the y is on the left side. So the only thing that's also on the left side that we need to move is this negative 4. And when the negative 4 moves over to this other side, it's going to become a positive 4. So I just move this negative 4 over here. Now it's a positive 4. And 9 plus 4 is 13. And now it's in slope-intercept form. So this is pretty easy because it's very similar to what we've done with equations. All right, and let's do one more. And this one's the not as nice one because there will be a little bit of fractions in here, but it's not too bad. So first goal is let's try to get the y as much by itself as we can. And what we want to do is the y is on the left side, which is good, but we need this negative 2x to move to the other side. So when it moves to the other side, that negative 2x becomes a positive 2x. And oops, that kind of skips a step here. And it becomes negative 3y equals 2x plus 9. Oh, sorry, it looks like my transitions are kind of messed up here. So if you kind of ignore the bottom part for now, how about I kind of cross it out for a moment? There we go. It's like, go away, ignore it for now. All right, so this became this right here. We just moved that negative 2x to the right side, so it became a positive 2x. Now when you look at this equation and you ignore all the craziness I left below it, you see that the y has a negative 3 attached to it. And when we solve equations, say you had something like 2x equals 4, you would divide by 2 on both sides to get x by itself. And the same thing applies here. If we want to get that y to be just y, we need to divide everything by a negative 3. And so I divide everything by negative 3 because what happens here is this negative 3 and negative 3, they both become 1, which leaves y by itself. And 2 over negative 3, that can't really reduce anymore, so we just leave it. But 9 divided by negative 3 can become smaller, and it can become a negative 3. So when we reduce that, this now became y by itself. Okay, this is now negative 2 over 3x. And 9 divided by negative 3 gave us negative 3. And that was it. I think that's probably the most complicated one, and we'll spend some time reviewing it a little bit more in class too. All right, you have no more practice problems that you have to try, and that is all that you have to do. And if you have any questions, we can go over it in class the next day.